screen. Okay, good. I hope you can all see my presentation now. Yeah, then again, welcome to our webinar about the Open Research Knowledge Graph. And before we directly jump in and start working with machine actionable data, I would like to take a step back and look into digitalization in our everyday lives. We are here at TIB in Hanover. I'm at the office right now, and if you wanted to visit my office 50 years ago, you would have to go and buy a map for Hanover, look where is TIB in Hanover located, and you would have to navigate there and go there. If you want to do the same task today, that's fortunately a lot easier because you can just enter TIB Hanover into Google Maps or any other navigation app of your choice, and it will directly lead you there and also give you the route automatically. But not only that, you will also gain additional features. For example, you can zoom in, look for interesting places around, look for maybe the nearest coffee shop. By taking that knowledge of which roads exist, where they lead, and so on, and separating this from the analog medium of the map and transferring it to a digital medium, the navigation app, we don't just have an exact copy of the analog map, but we really have a new system that allows us to do so much more with it and use more features and really makes it easier for us to navigate places. So we don't only see this with navigation, we see this in other parts, in other industries as well. For example, with mail order catalogs, where we would nowadays just use online shops instead. Encyclopedias, phone books, all of this we have transferred into the digital world at some point, which makes it easier for us to get information out of these things. But that was all for everyday life. How does it look like in science specifically? So in most of our everyday work lives as scientists, there our journey of how we are communicating information and how we are accessing information starts a long time ago. Over 300 years ago, the first scientific journals came up. And if you found out something new, you would publish it in this journal and another person could read this article to interact with the information. A bit more to our age, 100 years ago, basically still the same, but with nicer print techniques. And then roughly 20 years ago, we switched from printed out articles to mainly online articles in PDF form. And today also mostly if we want to learn about a new scientific discovery, we go and read the paper about this. Also, if we want to communicate our new scientific discoveries, we write a paper about this. So if you look at this evolution here, to phrase it a bit provocatively, you could say, yeah, not much has happened here from over 300 years ago to today, because yes, we switched from printed out articles to PDF versions, but that is not harvesting the full potential of digitalization. Basically, if you compare this to the real world example, that would be like taking a PDF scan of this analog map and posting it on a website and then say, this is our new digital navigation, which of course would work, but would just not be as nice and not offer the possibility for as many features as the navigation app. So instead, so we have this situation with information buried in PDFs in a rather static form. And the downside of this really shows because while it was feasible to read the scientific canon in a specific field 300 years ago, when there was just not as much published, it's not really feasible anymore today. We have more than 2 million new publications per year just in science and technology alone. And with that flood of publications, researchers are often lacking an overview. So even in small, very specific fields, researchers complain more and more that there's just so much to read, and that looking for answers is like looking for the proverbial needle in the haystack. And an example of this could, for example, be seen with the genome editing technique CRISPR. If you search for it on Google Scholar, you get almost 500,000 results. So finding information on this is not the issue. Finding articles on this is not the issue, but you're not interested in finding articles. You're interested in finding specific information to answer your research questions. For example, who has applied this to butterflies, or how does it compare to different genome editing techniques, or is it feasible to use CRISPR for my specific problem, etc. And if you want to answer those questions, this list of documents does not really help you that much. And of course, a lot of researchers faced this problem, and researchers are not living in a vacuum. We as researchers, of course, also read the news. We read about new technology. We read about AI is now here to simplify our tasks. AI can be used at work. Newspapers already use AI to summarize articles, etc. And so, of course, the question that a lot of researchers are asking themselves is, can AI also help me with my problem, with my literature review, for example? And there are a lot of examples on how this could fail out there. For example, probably you have all seen headlines about ChatGPT hallucinating some sources. Maybe you have also read about complete fails of scientific models. But still, if done correctly, AI can be a good starting point for your literature review. And this is exactly one component of our system ORKG. That's ORKG Ask, a service that turns 1 year old soon. And ORKG Ask lets you search close to 80 million publications and find research you're looking for with the help of AI. And I'm quickly going to show you how that looks like so that you're not just stuck with my slides, but can also see something in our live system. So you can find the page at ask.orkg.org. And if you visit that, you can just ask your research question here. Just in natural language, you don't have to think about any keywords or something, just type in your question. I'm going to use one of the example questions here. And then here for that question, there is an answer page generated, which has a short summary based on the 5 most relevant papers. And it's always 3 to 5 sentence summary on the answers that these papers give to that question. And then when you want to have a more detailed answer, a more detailed look, you can scroll down and get this tabular overview over different articles here, the answer they give to your questions, but also, for example, a description of the methodology used in this research. And that is basically, that is basically one way to get in touch with information, to interact with information from scientific articles in your field. As I said, there are close to 80 million publications in that system that you can just ask your question against. Those 5 papers, you can select more if you want to have more than 5 papers. Here is a load more button. If you click it, the next 5 will be loaded, etc., etc. And also, for example, if you're interested in more properties here, so not just result methods, but maybe something rather specific, you can also ask for more properties. For example, you could say, maybe it has been a study here and I want to know the sample size of the participants or something. Then you could add another column here. And if it's sufficiently described in here, you would get an answer here for the sample size. For example, here there were 34 participants in that study. And yeah, so if you're logged in here, so I'm using that system without logging in, so you can really just visit the page and start. If you log in, you have some additional functionalities. For example, you could also load up your own library, your own publications list, and then search for answers in that. So the short answer is yes, AI can help me with literature review, and we developed ORKG Ask for this. Tips and tricks you can find on the website. So it's really made for specific research questions, not for everyday knowledge or author search or something like that, but really just for research questions. So how does this work? Quickly, we start with the query, then the most important articles are determined from our data set. So every article that is mentioned on the page really does exist and is not hallucinated. And only then the LLM comes into play to extract the information, present them to you, and then you can apply additional filters. So for example, like the publication date or something like that. It's also completely open source, so whoever is interested in that from a more technical side can check those links out. And also this being fully open source makes it fully transparent and reproducible. But so the question is, are we done yet? Do we not need any of the following presentations? This is already so cool and can help me with my research. But the answer is we are not completely there yet, because there's still that point about making the answer machine actionable. And if you look at the answer that ORKG Ask here generated, it's not completely machine actionable. So you can't really plug this into your own simulations, for example, and reuse this. You cannot really, for example, build some kind of visualization just based on this answer. So there are a lot of things you can still not do here. Also, all of this is just, just extracted by an LLM. So there has been no kind of crowd review on the correctness of those results here. So there is still a bit of a way to go in addition if you want to dive deeper into a topic. And to compare it back to our navigation example, ORKG Ask is an assistant that immensely helps us in dealing with a map here, but it's still not the navigation app, still not the digital thing that we want. And for that, to build this new system, it's time to really rethink the way we do scholarly communication. And the solution is not just to have magically better PDFs, but to really digitalize knowledge and not just the documents. So really take out the knowledge inside the articles and transfer it to a completely digital platform. And this is exactly what we are doing with the Open Research Knowledge Graph. So now the knowledge graph part of that. And as the name already suggests, this is a knowledge graph. To see what knowledge graph means in that context, we have to look a bit deeper into how information is represented. So classically, the form you in research all know to represent information is, of course, the scientific article, which is text with a bit of metadata, basically. And inside this text, there's a lot of information. So here on top, we have metadata. In the abstract, we have a research problem, the methods. If we would scroll down, we would have the material results, etc. So there's a lot of information that we as humans can extract, but unfortunately, a machine cannot easily understand it from that text. Yes, despite all the advancement in LLMs, for scientific information, machines do not have as much of a structured understanding as we as humans have about this specific research problem. And so this way of text cannot not fully be understood by a machine. So a machine can only give us limited assistance here based on texts alone. So then what would be the next way to represent this information? That would be to take out the information and put it in such a graph. So here in the graph, you have different nodes that are connected here. And you can think of that as really easy sentences of just the predicate, subject, predicate, and object. For the metadata, of course, this is easy. That could just be this person is the author of this paper. But then it could also go into more detail. So this paper talks about this specific research problem and has used this specific data set and I don't know, has used this specific method or talked about this specific bacteria or place or whatever samples. So you can really build up as detailed as you want this information inside this graph. And the nice thing about this graph representation is that a machine can actually understand that and now give you more assistance on interacting with knowledge. And what can you do? Again, I want to take you into our live system to not leave you stuck with my slides. If you go to orkg.org, you find the page here. And then under view, you can see different content types because basically the possibilities are limitless of what you can do with machine actionable data. One thing, for example, would be machine actionable comparisons. So comparison tables where you could automatically compare the contents of different papers towards a specific research problem. I picked an example here from COVID-19 research, where in total 31 research contributions have been going into that table, and where researchers traditionally would have to read all those 31 research contributions. Here they just get an easy tabular overview. They see, okay, where has the study been conducted, in which time frame, and then, of course, also what is the result, what was measured here for the basic reproduction number, what was the confidence interval, what was the underlying mathematical model that was used to, to estimate those numbers here. And with that, you as a human can already get a quite good tabular overview. But as you can also see here, some of those things are highlighted, are underscored. And those things are resources that can then also be used in other papers. So for example, if you go to Singapore here, you could also open that resource and check what other statements have been made about Singapore. So for example, in which papers has there been some talk about Singapore? What has been said about this in those papers? And via that, you immediately have a connection to other papers, you have a connection to other research, and you can build up your whole knowledge base then. So those comparisons are one thing you can do with the data. Another thing here would be to create review articles made up out of different parts of the ORKG. And those can then really be worked on by the whole community. They can stay up to date, a bit like Wikipedia articles. You can, whenever there's some new research coming out, it can be easily added. So it's not stuck in a static form like a traditional review article, but there can be new things added all the time. It can really be community curated by a huge, as a huge community knowledge base for researchers from your community. There are several other options what you can do with machine actionable data. I'm not going to go through all of them. If you are interested in accessing the data, you can also go to data access here and then access it, for example, also via our Python package to use the data in your own research. So to not go through all of the possibilities here, there are a lot of things, and I'm sure the following presentations will also make it a bit clearer on how this exactly works and what would be the advantages of such a machine actionable representation. So the question is then, how does content get into the ORKG? So basically, who does the translation from article to knowledge graph? And machines, I already said, do not possess the in-depth understanding of research that would be needed for this task. So machines are, unfortunately, despite the, of course, big advancement in LLMs, are not precise enough to do this. So that leaves us with the other option of people. So scientific communities come in and put their content, put their knowledge inside that graph. And currently, for everyone who is interested in doing that, I have good news, because currently you can also get paid to do this We currently have our curation grant program running, where you can join us for half a year and curate content from your specific research field, maybe the topic of your PhD or your postdoc work. And you can get paid for this half a year with €400 a month to create content here for the ORKG. Yeah, as I said, you find us at orkg.org. You can contact us anytime at info@orkg.org and follow us on social media as well. And with that, I gave you an introduction of what the ORKG is. And I'd like to hand over to my colleague, Carrie Dean, for a demonstration on how you could start creating content, how you can get started with the ORKG and bring in your knowledge there to curate a knowledge base for your research topic, and then of course use the data for your work.
Yes, thank you, Annalena. Hi everyone. So today I'm going to show you how to create a comparison in ORKG. First I will share my screen. Yeah, so here I'm in orkg.org. Do you see my screen? Okay, great. Yeah, so here I am in orkg.org, and as you can see here we list one of the main content type in ORKG, which is comparisons, and you can browse them by research field. You can just select one of the research field from here, or you can search from this box, and this will filter out the comparisons that we have here in the website. Yeah, and in this tutorial, I will show you how to create one of those comparisons. Yeah, for that, I will close this website, orkg.org, and I will go to sandbox.orkg.org, which is mainly used for testing, because now I'm going just to create a demo comparisons specifically for this tutorial. And as you can see, this data will be deleted later on, as mentioned in this notice. Yes, to start, I will how to close this. Okay, yeah. So to start, I can first you need an ORKG account, and you can create it freely, and it's easy to create. And then I go to add new, and then comparisons. Here you can see an overview how you can create the comparisons, and also yeah, this can be done via 3 steps. So the first step is to import any existing data, and for this demo, I assume that we don't have any existing data, and we'll go directly to the step 2, which is the contribution editor. So I click on this button, go to contribution editor, and then I can add here the data that I want to compare. Before starting adding this data or creating this comparison, I would like to go back to the main page to show you what we are going to create today, which is this comparison. So I created it before, so I can show you the final result. So I will open this comparison. As you can see, it's a comparison of rechargeable battery technologies based on energy density and efficiency. Yeah, so as a disclaimer, so I'm not and materials scientist, so maybe there will be some data that it's not correct. Yeah, as you can see here, we have 4 columns, and each column represents a paper, and the rows represents the values reported in these papers. And we have one artifact attached to this comparison, which is this visualization. Yeah, so as we mentioned, we can go to add new and then comparison, and let's go to contribution editor and try to create that comparison. So the first step is to add a contribution. For now, you can consider a contribution is a paper. We are calling it contribution because mainly a paper contributes to science, so that's why we call it a contribution. I can click on add contribution. So to add the paper, you can search the paper by title or DOI within the ORKG graph. So maybe your paper already exists in ORKG. And if it doesn't exist, you can just create it from here. For now, I assume that the paper doesn't exist, so I will try to add it to ORKG. and I click on add new paper. To add new paper, you can enter the metadata manually from here, or you can just provide the DOI and look up the metadata from our one of the external services. There is also possibility to enter a BibTeX if you have the BibTeX. So we will extract the metadata automatically. And you can also maybe upload the PDF of the paper and we will try to extract the metadata. Yeah, I will try to copy and paste the DOI of the first paper. I have it here. I will just paste it here and then click on lookup to fetch the metadata automatically. Yeah, as you can see, the metadata is fetched automatically from external services. And the next thing, I think I need to provide the research field. Yeah, so you can just click on choose, which is, I mean, here you can select the research field addressed by this paper. And for this case, it will be materials sciences, material science and engineering. And yeah, you can browse also the papers from here, the research fields from here, or you can just search for it from this box as I did now. And then I click on select. So, and then I can just click on create to add this paper to ORKG. As you can see, the system detects that the paper already exists. So I will try just to change a bit the metadata so it doesn't complain about the existing paper. And I will just create it again. Yeah. As you can see now, we have a new column which represents our paper, but we have empty data. So the next step is to add or describe this paper. And one of the properties that we are interested in is the efficiency. So I will add this property and I click on add property and then search for efficiency. Yeah, I have it here. So if I click here, a new row will be added to this table and I can provide the values. Sometimes you may find that the property doesn't exist. So if you don't find the property, you can just try to create it. So I'll try to create it now, just to show you how it looks like. So you can click on create efficiency test this property, and then you provide the description for this property. You can also use one of the AI tools that we have in the system. So that will generate a draft version of the description. So if I click here, we will use LLMs to create a description for the property. And I can click on insert and maybe then fine tune this description to match my usage. I will close for this now because this is just for testing. And so the next step is to provide the value for the efficiency in this paper or the efficiency reported in this paper. And to do that, I just need to double click on this cell and it will give me the input field to introduce the value for this paper. And for this paper, it is 0.875. And then I need to choose the type of this data. So this data is not a text, so mainly it's a decimal, or it can be also an integer in other cases. And we have a long list of data types, so it's better to choose the most suitable or the data type of the value that you are introducing. So for this case, I will just choose decimal. And then I click away from this, and it will be saved in the system. Now I need to add the rest of the properties or the data reported in this paper. And I will start from the confidence interval. So I'm interested to report the confidence interval. So in the confidence interval, we have a lower limit and the upper limit. I will just add them quickly here. As you can see, sometimes there are multiple properties that look similar, but I think it's better to choose the most appropriate one for your case. So we have the lower limit and we have also the upper limit. And I then introduce the values. So double click again, and then I choose decimal, and then I enter the value. And for this case, for the lower case, it's 0.85. Click away, it will be saved. And then again for the upper limit, which is 0.90. Yeah, it's decimal again, and then I click away to save the value. Yeah, so now I reported all the values reported in this paper. I need more properties. Maybe I can report also, or one of the things that we are interested in ORKG to collect is the research problem. Maybe I can also introduce the method used to collect, measure this efficiency. And that is reported in this paper, and then I got it from here. So for the method, I have the method here. So the method used is empirical. Yeah, it's this one. So empirical performance analysis. And for the research problem, mainly it's the same one for all the papers that I'm going to add now, which is efficiency, rechargeable battery performance, and durability. As you can see, it's the first value proposed here because I just created this comparison, or I just created those values. So that's why they always appear at the top. I will add it from here. Yeah, maybe I'll also add another property, which is the battery type studied in this paper. So I have it here. I can search for it also. And the battery type for this paper is sodium. Yeah, for this case, I need to introduce a resource and not a simple text. So I will select resource and then I say sodium ion battery. So the difference between resource and the text is that resource I can link to it from other papers. So if there is another paper that reports the efficiency on sodium ion batteries, I can reuse the same resource, and then it would be easy or to know which papers are using or addressing this battery type. I think in the introduction with Annalena, you saw how we relinked or used the resource Singapore, and we linked many papers to the same resource. Yeah, and they can also, I think now I selected the data from Wikidata, so I can see directly the introduction of this kind of battery. Yeah, maybe I'm also interested to know the period that this efficiency was calculated. So I can add maybe the measurement period. And for the measurement period, I will need to create a resource called period because I want to group the information of the beginning and ending of this period time. So the idea is that I'm not going to create a resource that can be linked again, but it's just a resource to group the information that are related to a specific topic. In this case, it's a period. So I click on period and then describe the information that I have here. So period, normally there is a beginning and ending, and I will add them now. So beginning and also ending. And for this paper, the data or this measurement was calculated between, I will first need to enter the type, which is a Gregorian year. So this was calculated between 2010 and the ending was, I need to select the type, Gregorian year, and then 2016. Yeah, so for now, let's say I finished describing this paper. So the next step is to add more papers. So let's add the second paper of this comparison. So in this case, I will search by title. So the second paper is lithium. So the paper is already in ORKG, so I'm not going to recreate it again, but I will just use the paper exist on ORKG, which is already described by me previously. So I will select this one and I add a contribution. As you can see now, we have two columns and we can see like the values of this paper are loaded automatically from the graph. I can add more papers. Let's add the second and the third and the fourth paper. And in this case, they are this one, and this one. And I hit on add contributions. Yeah, sometimes papers do not report the values that we are interested in, and as in this case, some papers, let's say this one, reported energy density, which is not reported in other papers. But let's assume that in the paper that I'm going to that I added recently, I found the value reported in the paper, and I can click here and add the value, which is a decimal value, and it is, let's say, 160. It's an integer. And then I click OK to save the value. So once I finished, I can go to the view comparison to see the comparison of these papers. So I click here. So the system will try to create a comparison based on the values provided in these papers. And the next step is to create this comparison. So this is just a draft version. So if you are not happy with the values or you made a mistake, you can just go back and correct it. So I click on create comparison and I give the comparison a title. So in this case, I will just give it test title and I create. And then I visit the comparison. So this is the comparison that I have now, but it's not published yet. So that means we did not create a snapshot or persistent view of this comparison. So to do that, I need to first to improve maybe the readability of this comparison. So first I need to click on edit and then maybe provide a description for this comparison. So it can be easily find it later on by other researchers. And I need to choose the research field. So material sciences, the same as the papers. And then I introduce the author. I will just introduce myself here as an author for this comparison. And then I click on save. Yeah. So the next step maybe is to rearrange the properties to make it more readable. So maybe I will move the research problem and let's say the battery type to the top. I will move also the method used. And one of the interesting properties in this comparison is the efficiency. So maybe it makes sense to move it to the top. So we have the efficiency and then the confidence interval of the efficiency. And then we will have the measurement period with the beginning and ending. So as you can see, period here is the same value for all the resources. Maybe it's better to hide this property. And to do that, we can just customize it by clicking on actions and then select properties. I just need to uncheck this box, measurement period, and it will be hidden from the comparison. Yeah. As you can see now, I have directly the beginning and ending of the measurement. And yeah, once I'm happy with this comparison, I can publish it now, as we said, and we create a persistent snapshot of this view. And to do that, we just need to click on publish. And we can, of course, also assign a DOI to the comparison, so we can maybe reuse it in papers or refer it in our research materials. Yeah, for this case, I will just click on publish. And yes, so this is our comparison now. And if you want, let's say, to improve this comparison, maybe add a new papers or correct some values, you can just click on edit and then fetch the live data. By doing that, you will get the view where you can customize the view of the comparison. But to edit the values, you need always to go to the contribution editor, and you can do that by going to actions. Let's first create on edit, and then actions, edit contributions. And this will bring me back to the contribution editor where I can add maybe papers and also correct the values. Mhm. Let's say I want now to correct the description of this, or maybe the title. I will set the correct title for this comparison. Let's say it's about battery performance and durability. I'll just change the title. So let's say this is the improvement that we have on the comparison, and then I click on save and then publish it again. Let's assume now, since we have like some numerical values in this comparison, I can create a visualization or maybe create a chart from these values. So to do that, you need just to click on edit, fetch the live data, edit again, and then we click on edit visualizations. We add new visualization, and then I select which properties that I want to visualize. And for this case, I'm interested to visualize the efficiency, which is a number, and also the confidence intervals, which are also numbers. And then I go to visualize, and I can select the visualization method. And for this case, I can select maybe bar chart, column chart, and so on. And I can also add maybe the confidence, this is just the efficiency, but I can add also intervals. And I can click on this button and select maybe the lower and the upper limit. Yeah, maybe for this case, it makes more sense to select maybe a scatter chart. And yeah, and then if I'm happy with this visualization, I can publish it and share it with other researchers. I just click on publish and I provide the metadata for this visualization. Yeah, this is it. Yeah, once I finish my editing, I can publish this comparison again to create a new version. So this is kind of creating a history of the comparison. And also we are creating a snapshot for the view on each step. So I will create now a new snapshot by clicking on publish. Yeah, so this is our latest version of the comparison, as you can see here. Yeah, this is it. And I think I go back to Annalena.
Okay, thanks for teaching us how to create a comparison in ORKG. Next up is my colleague Lauren, who will present an entirely different approach to get your research data machine actionable. And with that, the floor is yours.
Thank you so much, Annalena. So hopefully you're able to see now my screen. Yes. Okay, great. So yes, my name is Lauren Snyder. I'm a postdoc working at the TIB with the ORKG, and as Annalena said, I'm going to present a slightly different approach. So rather than trying to extract knowledge from PDF articles in some way, I'll show you a new approach that we have created that allows us to produce our scientific results in a machine-readable format from the outset. So first I want to take you back to this slide that Annalena had already shared with us. So as she explained, if we think about how we create and interact with scientific information, it's very different from how we have these digitalization tools and other aspects of our everyday lives. So looking at the first articles that were produced in the 1600s compared to what we're producing today, not much has really changed. We still rely on text-based articles to share scientific information formally. So in this 400 years, we've managed to switch from physically printed articles to PDFs, but that's about it. So if we come back to that navigation example that Annalena also mentioned with Google Maps, it's like we're living in a world where we never developed these navigation apps, but instead we're relying on PDF scans of maps. So in science, we now have these PDF articles that we can easily share electronically and that allow us to organize structured metadata using reference managers. But most of the scientific information that we're publishing in these PDF articles cannot be organized in this way. And why is that? It's because we're not producing it in a format that machines can interpret without human assistance. So in other words, it's not machine readable. This means that we're burying very important scientific information in these unstructured text-based articles. And this limits our ability to use digital support tools to make the research lifecycle more efficient. So one example I like to talk about is thinking about doing something like a meta-analysis, where you have to find, extract, and organize large amounts of information. And here information extraction presents some challenges for us. So if we do this manually, it's time consuming and it's prone to error. And if we use some type of semi-automated extraction approaches like large language models or text mining, certainly we can speed up the process of knowledge extraction, but there's a trade-off in terms of how accurately that information is extracted, right? So this is an issue because if we want to address pressing challenges like climate change or biodiversity loss, we really need to be able to efficiently and accurately organize information from complex data sets across different articles. But what if we could produce our scientific results in a machine-readable format? Then, like with navigation apps, we could leverage machines to interact with this information in new ways. Reborn Articles is a new open source approach that allows us to do exactly this, produce our scientific results in a machine-readable format from the moment they're produced. And we recently created a new digital library called ORKG Reborn that's designed specifically for Reborn Articles. And this approach integrates with programming languages that we researchers commonly use for our data analyses, like R and Python, and it ensures that the scientific results we're producing are born readable by humans, but also by machines. And this is where we get the name Reborn Articles. By producing results in a machine-readable format, we enable the ORKG Reborn digital library to automatically collect and organize them, which reduces the need for post-publication information extraction. And we've now prototyped this approach on several different scientific articles. This is an example of a soil science article that was published by the journal Copernicus, or by the publisher Copernicus in the journal Soil. And what we did was add a few lines of code to the R script that the authors had originally developed for their analyses. And this additional code calls an R package called dtreg, which uses schemas or data types to structure the results of their analyses in a machine-readable form. So as a result, we can transform information from an unstructured text-based format, so a PDF that's not machine-readable, into a highly structured machine-readable format that can be automatically collected by ORKG Reborn. This means that researchers can now download the data associated with this article as CSV files, and they can also copy the underlying code that was used to conduct the analyses into a computational environment like RStudio so they can actually recreate the results for themselves. So to summarize, by implementing the Reborn Articles approach, machines are now able not only to collect the metadata of an article, but also the main results. So I know we just have a few minutes left, but I'll just quickly show you what this actually looks like in ORKG Reborn. So here's the digital library that I've been talking about. And if we go to this soil science paper I mentioned, we can see some metadata related to this article. So here's the title of the article. This is the year it was originally published in the journal Soil. And this is the DOI that takes us to the classic PDF article that we would find in this journal. If we go back to ORKG Reborn, we can see that this Reborn article also gets its own persistent identifier. So there's a DOI that specifically references this Reborn article. So this can also be cited in addition to the traditional PDF article. And the way that we structure information in this digital library is in the form of scientific statements, or these might be similar to the results that you would find in the results section of an article. So for example, here is one scientific statement that the authors made, and underlying the statement is the scientific evidence or the scientific results that were used to arrive at this statement. So if I click on this statement, I can see all of the analyses that the authors conducted. So they used these descriptive statistics, they used a particular function that's associated with a package in R, and I can see the exact code that was used to produce these results. I can also see the input and the output data associated with them. And now, oftentimes you might find, if you're lucky, the input data, the raw data that researchers use for their analyses in a data repository like Zenodo or Dryad. But it's often very difficult to reuse this information because it's not well documented. It's not structured consistently across publications. So here you can see the author used this language to describe the column headings in their data set. So to me, CC variant may not mean very much, but if I click on this, I can understand, because we've linked to ontologies, that this is a type of cover crop. So even though the authors maybe didn't add this level of description to their original data set, by making it a reborn article, we can bring some additional structure and semantics into this so that it's easier for other researchers to use, but it also can be linked to other data. So this is just a brief example to show you what a reborn article looks like. And I'll go back to the presentation now. So just to show you as a grantee kind of what you would be doing. How do we get to this, right? So how do we produce these reborn articles? So what we do is we work with the original code, the R or the Python code that the authors wrote to do this analysis. So here's an example from a different reborn article we have from marine biology. And the author was running a permanova analysis in R. And now we want to capture the structured output of this analysis. And so then what we do to implement the reborn article approach is we call, as I mentioned before, this R package called dtreg, and allows us to add some code that's going to call a template or a data type. And this just guides us through capturing some key information about the analysis. So for example, here I've called this statistical test of difference template, which allows me to pull information from this analysis related to the input data and to some of the variables that were used in the analysis. So this is just one part of the template. It's not the full thing, but it gives you an idea of the type of information we're capturing and how we structure this information in a way that machines can then interpret. So once we filled out the template, we then save this machine readable information as a JSON file. So this is just a file that machines can then interpret. And then we interlink this JSON file to the DOI of the original journal article. And this is the step that allows ORKG Reborn to automatically collect this information via a DOI lookup function. So this is exactly the work that you would be doing as a grantee, would be identifying journal articles where researchers or authors have provided the underlying data, but also the code in either R or Python to do their analyses, and then structuring the outputs of this using the dtreg package. And once again, this is what it looks like, and you can find and get some more information about ORKG Reborn at this address here. So with that, then I will hand it back to Annalena.
Yeah, thanks, Lauren, for the presentation of the Reborn approach. So for those interested in the grant program, you have the option to work with both. So either the Reborn approach or the way that Caroline presented, to go to ORKG and create comparisons there. I'm posting the link towards our call for applications to the chat. So if you or anyone from your group, anyone in your contacts is interested in joining us for half a year to work with the system, then feel free to apply there. Usually we have a nice group of around 10 researchers that work closely with us. And it's always been a fun program, so I can always only encourage everyone to apply here. And with that, I'm stopping the recording now.